The first speaker is Francois Van Heerden. He's a senior analytics researcher with Kantar, and he will talk about R package trends in South Africa.
All right, welcome everybody. So my talk is on understanding the state of R. So before I begin, I actually didn't think I was going to be the first speaker for the day. And I thought by myself, oh dear, bringing bad news about R on the first session would be kind of crappy. But at least you can all be aware or can be relieved that it's not the case. So yeah, before I begin, a little bit about me. So I'm originally from a research psychology background. I finished my master's and I'm currently working for Kantar. So as Kantar, we do a lot of market research. Specifically, we help companies with their business needs and any of their data science requirements. Globally, we have offices everywhere, and that is just a small bit of our offer. But anyways, let's get into the talk. Okay, so what got me onto this talk? So originally I saw a tweet with this map, and I was kind of curious to know where they were getting the data from, specifically where they were getting the data from and what the actual number was for South Africa specifically. So kind of diving into it, I could see that South Africa had 6,752 downloads, and they were making use of CRAN downloads. But kind of in exploring that, I realized that we could also actually see package downloads globally and not just R downloads. So that kind of got me thinking, can we do something more with the data that we have rather than just trying to assess what the usage is in South Africa only based on R downloads itself? And it actually turned out, in my mind, that looking at R package downloads actually shows far more. So kind of thinking about it a bit more, people can download R, but that doesn't mean they're necessarily using R. So package downloads on the other end, likely when you have a certain problem, you'll download a package and that will assist you with your problem, and that will far more indicate you using it for something specific at that time. Also kind of just elaborating a bit on it, if you think about your data science journey, you'll likely be downloading more packages as you go along, and as your needs change, you'll also be downloading different packages. So this was kind of my rationale for looking at this. So in terms of what we actually find on CRAN, you will typically get a log data file that will contain those variables. The most important ones for me were really the date, the package, and the IP ID. So all those are pretty stock standard. The only one to really talk about is IP ID. So in short, we have this daily unique ID assigned to each IP address. So per day, we can see what people were downloading, but we can't see across several days or across a week what people were downloading. So in some ways, that's a bit of a limitation, but this was a way to prioritize the user's privacy, but it's still, we can still actually use it. Also just to note, since IP ID is based on IP address, we don't necessarily know if one person or 4 people are downloading through that one connection. But that's also just a bit of a constraint that we can actually deal with in some way. Okay, so getting to the data, I first had to download all the log files, and this took quite a while. I downloaded from 2015 to 2018. And you might ask, what was the reason to download all the other years worth of data, given that we're looking at 2018 today? So this was specifically to do the time series that I do later on. And you can't actually really look at a trend only on one year. You do need the other years to really look at the seasonality effects that are at play. All right, so I had to download 1,462 files. That was 17.6 gigabytes compressed. And then reading it all in took quite a bit of time. So what I did is I finally read in 30 days, these little mini lists of 30 days each, and it was essentially 49 sets that I had. I then only had to find a way to combine them in the last step, and there was the data frame. Kind of just to show you, our final data frame consisted of 5.7 million observations. And 2018 was 2.8 million observations. So I hope that's a bit of terrible foreshadowing of how bad 2018 actually was. All right, so there's just a print of the data frame so you can see what type of, how it actually looks. And then kind of just to get a very broad sense of what was happening in the data, I opted for 3 simple graphs to really put it into perspective what was happening. So first monthly downloads, day of the year, and then day of the week. So when you look at monthly downloads, we see this very interesting plot where there's a lot of activity happening in the second half of the year, where we also have this very slow start at the beginning of the year, and then we finally have this mid-year dip that we see. It's also quite interesting to note that the activity of downloads in January and December are almost equal. So kind of just to zoom in on this picture, we can look at the day of the year. Now, I really like this graph, but it's far more impressive when you have the whole screen to show it. But you can also see something of that same trend that we just saw up top in here, but it's just spread out a bit more. What's also actually quite interesting to note is this almost jaggedness that we see, where we have these very high spikes on certain days, like here in the second half, specifically in September, and in other points throughout the year. There's a very simple explanation for this, and you kind of only see it when you look at the day of the week. So in looking at the day of the week, it becomes very obvious. On Mondays, we all download the most. Tuesdays is a bit of a decline. Wednesday, we actually have this midweek slump. Thursday's a bit of a pickup. And then going into the weekend, downloads are on its lowest. So I think looking at all three graphs, we can see that this is quite strong to our usage case. When we're working, we're downloading, and there's quite a one-to-one in some ways looking at this. All right, so with these kind of trends in mind, it's finally time to get into the decomposition. So before doing the decomposition, I also just decided to look at how that data would look if we plot it. And it looks something like that. So you can see the break of December, January at every bit, and we basically have 4 years worth of data shown there from 2015 on the left to 2018 on the right. So you can actually see over time the volume is definitely increasing. But we can't just go on that alone to really look at how good the trend was. So I can't go through time series in detail, but in short, most of the time when you look at your data in terms of a time series perspective, you'll have 4 components to your data. You'll have a trend, you'll have a cyclical, you have a season, and you'll have a remainder. In some instances, and in the technique I used, cyclical and seasonal are grouped together, and we can represent it with the formula on screen. So essentially, I just made use of the stats package, and it has this very convenient function called STL. Now, STL stands for Seasonal Trend Decomposition Procedure based on low S. So it's basically a filtering procedure to decompose a time series in those 3 aforementioned components. So in short, this method uses iterative low S, so locally weighted regression, smoothing, to obtain an estimate of the trend, and then the same type of smoothing again to extract a changing additive seasonal component. So the remainder is just basically subtracting the seasonal and the trend from the bulk of the data. So in terms of the code, it was very simple. It was just converting my data into a time series friendly format, and then actually just putting it through into the stats package. And that is what we end up with. So I think the first thing to really note is that the trend line is very strong. We can see quite a strong uptake from the late 2016s onwards, and 2018 was a really good year. If you look at the seasonality, we see a bit of an uptake at the beginning of the year, almost about Feb, March, and then we see this drop-off happening on the December-Jan period again. What is quite interesting to see is that in terms of the remainder, we see that there's that second half of 2018 that has this big usage that's actually extracted in the remainder. So that's a bit of an anomaly. I couldn't really tie it back to any specific event or thing that happened, but it's probably concentrated use within that period. So that's also quite interesting to note. But nonetheless, it's a good trend. I'm actually quite happy to see that result. All right, so I just have a couple of points there on what I think actually motivates this trend. So it's likely that more and more academic institutes are using R, and likely businesses have also seen the use case for R and are more so pushing for it. And then aside from that, I think there's also a general drive towards data science more so, and more people picking R up for that reason. And then lastly, I think also R maintains a very strong presence online within data science communities, and that probably has also led to this trend that we see. All right, this is the first half, so getting into package downloads. So just to get into package downloads, I did a simple group by, produced some simple statistics, and this is what we ended up with. So we had 14,156 unique packages downloaded for South Africa in 2018. On average, a package was downloaded 203 times, and the median was 23. So actually, we see that we have these small set of packages that are downloaded a lot, with this long, never-ending tail of packages that are downloaded very infrequently. In terms of the top 100, and I'm sure this is actually what people want to see, this is what we ended up with. So I have a full printed list, but there's just something to show you of how quickly we decline from 30,000 plus downloads in a year to the sub 10,000 mark. It actually happens quite quickly, even within the top 100. But in terms of the leading packages, I don't think it's to anybody's surprise, but RCPP was actually ahead quite far. Yes. rlang, stringy, ggplot, tibble. And then as we kind of move on, you'll see things like dplyr still popping up, CRAN, reshape, rcolor, readr, HTML tools, evaluate, haven, forcats, tidyverse, car, ktools, xtable, and so on. Shiny, I think, was on 63. All right, so this was kind of one way to look at this data, but I actually really want to do something that goes beyond the descriptives. So thinking of what we had in the data, we could actually represent an IPID downloads in this way. So you would have 3, or let's say a user downloaded those 5 packages. We can also actually represent it as an age list on the right. Okay, so that blue is not showing well, but that is the stats package. So essentially, we can just take the initial list, we duplicate that list twice, we cut the the last entry from the first set, and we cut the first entry from the last set. And then essentially, we just group them together. So I wanted to represent the downloads of people within an edge list like this. So essentially, we could, and in a very basic example, sorry, this mouse, would be like this. So we can just represent the 5 packages like this. So we have 5 nodes, and then all the packages are connected with these edges. And then kind of just thinking of a bit of a more complex example, we could have something like this, where somebody downloaded caret stats leaflet, but then they re-downloaded caret later. So these would have a degree value of 2, whereas these would have a degree value of 1 on the right. So kind of following this logic, I applied the same thing to the data that we had. So it was just about getting the data in again, and then creating a unique ID for each IPID for each day. So having that in, I could just simply go through the same process of copying that initial list twice and going through the procedure of getting the to and from. So after having all of that and creating my node dictionary, getting my nodes up and creating my edges, it was just a simple matter of getting the package to really show it. And the data looks like that, unfiltered. So that's 14,000 nodes, completely unfiltered. That is pretty much how our downloads look throughout the year. So this is quite a bit of a monstrosity, and I wouldn't implore you to try and create this object. I did it as a PNG because the original object was quite big. So yeah, looking at this, I thought to myself, this is an initial result, but it's not really telling us much more. So I had to find a way to really prune this network to get something more out of it. So essentially what I did is that I made my edges to be truly undirected. So depending on the to, from, and from to combinations, they were added together. And then I filtered the weights of the edges based on 100. So a connection had to be used, or an edge had to be used 100 times or more to actually be part of the final visualization. And that got us to something like this. So I created 2 versions of this. Both of them are interactive. The second one is one that I'm going to go into detail. But basically, when I got to this result, I realized that I can change the nodes based on how well they are connected. I could add in some color, and I could make the edges thicker depending on how often those points were used. So there's the final one. So if we kind of dive into it, we have packages like, this mouse. We have packages like RCPP here, there's ggplot, for instance, and our big packages are in the center of our network, as you can see. So it kind of holds true that packages that are downloaded a lot are also often used with other packages, which is quite intuitive, but the network actually shows you a bit of evidence for it. What's also quite interesting to see is that we have this OffMoon Crescent here, almost at the side of our network. And that's essentially just smaller packages that have now at least formed some stronger connections. And as time goes on, they'll finally find another package closer into the middle of the network and connect as they get used, depending on what the use case is. So it's also quite interesting to see about this visualization. If you want to write a successful package and your successful metric is how often your package gets downloaded, it's actually simple of just downloading or creating a package that supports one of the main packages within our download set, really. So There's a lot more you can do with this tool, so what I really like about it, and I haven't explored it far enough. So one of my favorite packages is E1071. So it's one of the best packages to do SVMs in R, for instance. So you can actually get a very good sense of what other packages are being downloaded with it. And you can quickly figure out which of those packages do I have, which of those packages don't I have, and which of those packages are actually directly relevant to what I need it for my everyday in using that package. So I am thinking of releasing it as a tool somewhere along the line. What is also quite interesting about this, so SF was supposed to replace SP. But if you look at where SP sits and where SF functions in this graph, it's actually quite interesting to see the kind of the repertoire that's happening. So we kind of have SF here on the side, not close to the network. You can see that SP is highlighted there, so there's some tertiary connection to it, but it's not very direct. Whereas when you look at SP, though, it's a very different story. It's far more connected and far more central to the network, related far more to some of our main packages within R. All right, so just my couple of last points. So these are some of my takeaway points after going through the whole process. So I think it's definitely clear to say that R is growing and the momentum is definitely there. So I think in some ways it's now about thinking of how to capitalize on this growth and kind of how to be part of the community and how to actually contribute. So that's just something to keep in mind. All right, secondly, I think it's really worthwhile to see that we've now have a more concrete idea of how R is being used, and that also kind of gives us far more information of what to do and how to do our everyday. My third point is a bit of a strange one, but if the network analysis was kind of overwhelming in any way to you, it kind of did its job. So just bear with me for a moment, but if you think about how complex that first network was, essentially we all have to kind of navigate that space in some way. And that's quite difficult to know which packages to download, for what reasons, why you shouldn't be using this package, and so on. So one of the quotes there from Stiger, Nash and Groves says, "Today the enormous number of contributed packages available to our users outstrips any given user's ability to understand how these packages work, the relative merits, or how they're related to each other." So you kind of have to have a strategy of going about how you're going to download packages, because otherwise you're going to burn hours, maybe without anything to show for it. So from their study, they actually had this result to show about how people discover and learn about packages. And it was quite interesting to see what a big role social media play and who we follow and who we interact with regularly. Okay, my fourth point is just that it's likely that the package proliferation will continue and it will become even more difficult to select a package. So on the one end, we really have a phenomenal open source community and our community helping with developing tools. But you essentially end up with the point where 3 or 4 packages are almost equally as good. And the question is, how many vignettes, examples, and documentation will you read before you select? So I think in some ways we are spoiled for choice, but it kind of spoils your choice. So that's just something to think about. And then the last point, so we now know something about the merits of the packages based on downloads, but that is not sufficient. So a lot of people have gone about different ways of trying to generate metrics for packages. And there's no real consensus as to what is the best. So that's just a couple to note there. Others on the other end are actually more and more motivating for the impact that communities have and actually realizing that more so some of our attention should be there. So that's just something to think about as to what the solution is. What I found quite interesting on a bit of a tangent, so Lucy McGowan developed this Shiny app called Classify. And it was initially used to classify functions within R. And we can essentially do the same to classify packages within R. There's currently no real way or consensus as to how we're classifying packages, how to differentiate them, and kind of working in the same principle of having a Shiny app through which we essentially play this game. We can classify packages and more so easily discern where to look for what and how to kind of navigate the space. Okay, thank you guys.